Let us continue with Pep Talks Education, Chemistry, Ordinary Level, Ionic Chemistry and Qualitative Analysis. So, we have been looking at how to prepare for heating a substance under test, and we looked at the possible observations we are going to make in terms of expectations. So we saw what to expect during heating. We don't just heat for granted. So now let us look at those observations here and their respective deductions. So if I heat and then make a particular observation, what is its deduction therefore? So remember that this one is now going to be part of what we are going to discuss in this case in our practicals, what we are going to find in this case in our practical when you are heating. So let us look at the observations and then the real deduction. That we are going to make from our observation. So, we started with water crystallization. Now let us see how to present the water of crystallization. So we have, let me use black. Colorless liquid droplets which turns white, anhydrous. Take note of the word anhydrous, it's one word, anhydrous copper to sulfate to blue. Carries liquid droplets which turns white, anhydrous copper to sulfate to blue. If we observe this one here, more especially on the cooler part of the test tube or on the wall of the test tube, then we have two observations that we can make in this case. You can say a hydrated compound. I said you can say a hydrated compound. That means this is one of your deductions that you can make, or but don't give both of them, just only one. Or you can say water of crystallization. I want you to take keen note of the spelling of the word crystallization. If you mess up with the spelling, then you are meaning something else, not, in this case, crystallization. So you can write either a hydrated compound or water of crystallization in this case. That is, if you have observed colorless liquid droplets which turns white anhydrous copper to sulfate to blue. This is one of the observations, and that is for water crystallization. Two, the gases. One of the gases is carbon dioxide. So carbon dioxide is, as it is produced, it is a colorless gas which turns moist blue litmus paper to red and turns lime water, one word, lime water, milky. So if you have got a colorless gas which turns moist blue litmus paper to red and turns lime water milky, then the gas is carbon dioxide. Therefore, we have carbonate ions. So, that is our observation, and this is the deduction. It is carbon dioxide, therefore carbonate ion. That means this ion is present as a result of the production of this gas here. So the gas comes first and it proves that there is this ion here. So that is with one of the gases, that is carbon dioxide gas. Let us look at another one. The colorless gas. With a choking, it's one word please, choking, with a choking, irritating smell, and which turns moist red litmus paper to blue. Oh, a colorless gas with a choking, irritating smell. It chokes you, makes you to stop breathing momentarily, and the smell irritates you. And that gas has got an alkaline effect on litmus, that it turns moist red litmus paper to blue. So it is an alkaline gas, and this only alkaline gas in qualitative analysis ordinary level that we discuss here is ammonia. It is NH3, and this means therefore there is ammonium ion. Anything you write, please write it quite carefully. Make sure that you put the whole of your attention on what you're writing, and that is with the formula of the gas produced and the cation or the anion which is likely to be present in that substance under test, or which is present. So you need to take note of that, and this is a presentation of ammonia gas. When it is produced, in this case, we are able to get that. If we get that ammonia gas, it means that there is ammonium ion. This is how heat helps us to detect the cation or the anion which is present. Let's go to another gas. That is a red-brown gas. Red-brown with a hyphen in the middle, which or with an irritating smell, and which turns moist blue litmus paper to red. So a red-brown gas with an irritating smell, and which turns moist blue litmus paper to red. So in this case, a gas with this distinct color here is nitrogen dioxide gas, and therefore it means that there is the nitrate ion. That means there is the nitrate iron. So this is just but one of the gases that may be produced in this case during heating. So when you heat a nitrate salt containing the nitrate ion, you are able to get this nitrogen dioxide gas, which has got a characteristic color of red-brown. That is that gas. Then we can also have a colorless gas with an irritating smell and which turns moist blue litmus paper red and also turns orange acidified potassium dichromate solution to green. So a colorless gas with an irritating smell, and the gas turns moist blue litmus paper to red, and it also turns orange acidified potassium dichromate solution to green. So this solution of acidified potassium dichromate is a confirmatory reagent for this gas. The gas is generally an acidic gas, just like even carbon dioxide, which is an acidic gas, even sulfur dioxide gas. In this case, say even nitrogen dioxide. Yes, they are acidic gases, but in this case, the confirmatory test for the gas is that it turns the orange acidified potassium dichromate solution to green. So the gas in this case is sulfur dioxide. And that means that you have heated a what? A sulfate which contains the sulfate ion. You can see how they are connected. A carbonate containing carbonate ion when heated gives carbon dioxide gas. An ammonium ion, the ammonium salt containing ammonium ion when heated gives us ammonia gas. A nitrate salt containing the nitrate ion when heated gives us nitrogen dioxide gas. And a sulfate salt containing the sulfate ion when heated gives us sulfur dioxide gas. So this is one of the gases. Let us look at another one. In this case, we can have, or we may have, in this case, white fumes with an irritating smell and which turns moist blue litmus paper to red. White fumes, not a colorless gas this time. White fumes, the fumes has got irritating smell and it turns moist blue litmus paper red. So in this case, the white fume is a sulfur trioxide gas, and this means that we have got sulfate ion. In this case, it means there is sulfate ion. So these are just but the gases that we are likely to meet. Remember, we still have other observations. In this case, we have the observation of, we have the decrepitating sound, the sublimate, and then the residues. So we are going to look at those in our next session. So Tech Talks Education, thanks for watching.